Welcome to Precalculus Concept 16D. We're going to identify horizontal asymptotes, and there's 4 boxes. So here is the first box, and what we're going to do is just sort of talk about what is a horizontal asymptote. So the graph that I have for you that we're working with so far is the most basic rational function. It's the graph f of x equals 1 over x. And so the idea here is that this blue horizontal line is the horizontal asymptote, all right? So the idea is that as our x values get bigger and bigger and bigger and bigger and bigger, or smaller and smaller and smaller and smaller on the left or to the right, the function behaves more and more like the horizontal asymptote, the line y equals 0. That blue line is the equation, the line y equals 0. And for bigger and bigger values of x, the further away that we get from x equals 0, the more and more the graph f of x behaves like the horizontal asymptote y equals 0. Many students think that a horizontal asymptote is a line that the graph will never touch and never cross. And in a way, that's kind of true, but it is possible for a graph to cross a horizontal asymptote if it's around the point 0. So a better definition is it's just a line, a horizontal line, in this case the line y equals 0 for our basic function, that the function behaves like for big and small values of x. And that's what a horizontal asymptote is, and all rational functions have some sort of a horizontal asymptote if certain conditions are met, and that's what we're going to figure out today. Here's another example of a horizontal asymptote. It's in a different location. Here's the rational function f of x equals 8x over 2x plus 5. And this blue line represents the horizontal asymptote. And in this case, I can tell that the equation is the line y equals positive 4 because it goes through the y-intercept at 4. So we're going to learn about how to find these things from the graph, but they don't necessarily have to be at 0. So there's another example of a horizontal asymptote for you. Okay, box number 2 is all about how to find a horizontal asymptote from the function. So remember that every rational function is in this form, f of x equals p of x over q of x. So whenever I'm talking about p of x, I'm talking about the one on top, and whenever I'm talking about q of x, I'm talking about the polynomial on the bottom. So what we have to learn to understand here is that the degree of each of these polynomials matters. So I have 3 examples for you, and they all look very similar. Example 1 is the rational function 3 over x plus 5. Example 2 is the rational function 3x over x plus 5. And then example 3 is 3x squared over x plus 5. So what we want to do is first identify the degree of p of x. The degree of p of x on the top here, the p of x is going to be a degree of 0, because it's going to be like 3x to the 0. So that's 0. The degree on the bottom is a 1. The degree on part 2, the degree is a 1, and then the degree down here of q of x is also a 1. And then on number 3, the degree of p of x is a 2, and the degree of q of x is still a 1. So here's the deal. In example number 1, if the degree is smaller of p of x than it is of q of x, then you are guaranteed that the line y equals 0 is the horizontal asymptote. You're guaranteed that's what it is, okay? So if the degree of the top is smaller than the degree on the bottom, then you're guaranteed y equals 0. What about if they're equal? Okay, like in this case, example 2, the degree of the top of p of x is equal to the degree of q of x. Well, if that's the case, then the line y equals whatever the coefficients are will be your horizontal asymptote. So in this case, it would be the line y equals 3 over 1, or in this case, y equals 3 would be your horizontal asymptote. We're going to do more examples of this one in a minute. But then take a look at example number 3 here. The degree of p of x is actually now larger than the degree of q of x. If this is the case, then there is no horizontal asymptote. There is no horizontal asymptote. So these are our 3 cases. If the degree on top is smaller, we get y equals 0 as a guaranteed. If they are equal, if the degrees are equal, we take the division of the leading coefficients to find the horizontal asymptote. If the degree of p of x is larger, there is no horizontal asymptote. Okay, here are 3 more examples for you. We're going to find the horizontal asymptote for each rational function. Example number 1, I have 4x over 2x squared plus 11x plus 5. The degree of top is 1. The degree on the bottom is 2. 1 is smaller than 2. So therefore, the equation y equals 0 is the guaranteed horizontal asymptote. Okay? In example number 2, the degree of the top is a 2. The degree of the bottom is also a 2. They are equal. So I take the quotient of the leading coefficients. So in this case, 4 divided by 2, or is the same thing as y equals 2, would now be the horizontal asymptote. In example number 3, the degree of the top is larger than the degree of the bottom, so therefore there is no horizontal asymptote. Okay, you try. Find the horizontal asymptote for the rational function 9x squared over 3x squared plus 2x plus 1. Okay, the answer is y equals 3. The reason is because the degree of p of x is 2, the degree of q of x is 2, they are equal. Therefore, I take the quotient of the leading coefficients, and 9 divided by 3 is the number 3, so the answer is y equals 3.